Hi everyone, and welcome to the last lesson of the whole year, the cosine law. So after this lesson, you should be able to recognize when to use the cosine law. And this is versus the sine law, because I think we know that we're going to use the cosine law and the sine law for non-right triangles. Okay, but the second question is about when do I use the cosine law over the sine law, because you can't necessarily use the sine law in every triangle, which we're going to talk about right now. And then I want you to be able to use the cosine law to solve triangles. Sorry for the messy writing there. Okay, so let's take a look at this triangle here, PQR, and let's talk about why we cannot use the sine law. So if you remember, the sine law was sine, in this case it would be P over lowercase p, sine Q over lowercase q, and sine R over lowercase r. And what we would do is we would pick like part of this equation, say P and Q, and we would put in 3 out of these 4 pieces of information and solve for the 4th one. But what you'll notice is with this particular set of information, we can't actually solve for anything, because if I write out the sine law for this, it would be sine 70 degrees over P equals sine Q over 4, which equals sine R over 13. And what you'll notice is you can't take like these two or these two or the other two and actually get 3 out of the 4 pieces of information. So in order to solve something with the sine law, you need to have like one angle side pair. And you'll notice that here, none of them, you don't have one full angle side pair. So the sine law can only be used when you know at least one angle side pair. Okay, and just a reminder, the primary trig ratio, SOHCAHTOA, can only be used on right triangles. Okay, so we're talking SOHCAHTOA here. Okay, those are only for right triangles because you know that the other 2 angles are acute, right? Okay, so what I want to do, and normally I would derive the cosine law, but what I want to do instead is I just want to tell you what it is. Okay, and you can use it in this course without the derivation, that's okay. Okay, so here we go. A, B, C. A, B, C. Now, here's the thing about the cosine law. You can actually write it in 3 different ways. So I'm going to tell you how I like to memorize the cosine law, because I think it's helpful to know. It'll help you understand the equation. Okay, so this is how it works. I'm going to start with a squared equals b squared plus c squared. It looks a lot like Pythagorean theorem, but the thing here is you don't have a right angle, so you don't have a hypotenuse. So any of A, B, or C can be in any of these 3 positions. Okay, now what I'm going to do is I subtract 2, and then whatever these 2 variables are, and these are side lengths, remember, A, B, and C are side lengths because they're lowercase. So I'm going to multiply B and C, which are the same as these 2 variables here. And then the last thing is cos of an angle. Now this angle at the end is always going to be the uppercase version of whatever this side length is. So I know you guys have open notes this year, so you don't have to memorize this, but I still think it's valuable to know know the relationship between this angle and the side on the other side of the equal sign. I think it's really important to know that. So for example, I could also write this in the following way. I could put b squared here, a squared plus c squared. So the b is on this side and the other two sides are on the other side of the equal sign. Subtract 2ac, and hopefully you've caught on that this should be cos uppercase b. C squared equals a squared plus b squared minus 2ab cos uppercase c. Okay, so when do we use the cosine law? Well, the most important case where you can use a cosine law, the one that happens most often that you can't use a sine law, is when you know three sides and you don't know any of the angles. Okay, the cosine can also be used when you know two sides and the angle between them. If you remember, we called that the angle contained within the two sides. Okay, so let's have a look at these four triangles and let's see if there are any where we can use the sine law. Okay, so we already talked about the first one. We cannot use the sine law here, but we can use the cosine law. Okay, we can say, for example, here, I know that this is my angle P. I'm going to write that. It's the only angle I know. So I know it's got to go in the end of my cosine law, the cos 70 part, which means that P squared is going to go on this side. And then I'm going to get 13 squared plus 4 squared minus 2 times 13 times 4. So that's how I write the cosine law here. And what we can see is I only have one piece of information that I don't know. So for the second triangle, let's have a look at this. Well, we know that we can figure out the third angle because we have two angles there already. Okay, so this is 64 degrees. So can I use the sine law? Well, I think I can because I have one pair, side angle pair. So I know that I can write sine 37 degrees over 13. And if I want to know what x is, it's going to be sine 79 degrees over x. So I know that I can solve this using the sine law. All right, what about the next one? Well, with the next one, I think I also have a side angle pair. If this is 63, I can write, sine 63 degrees over 22 equals, we can call this x, sine 75 over x. So I can figure out the rest of this triangle. But we'll notice this one's the cosine law, and it's most obviously the cosine law because we don't know any of the angles at all. Okay, so here's a case where I'm just gonna pick an angle, let's say, I don't know, B, okay, and I'm gonna put that in my cos ratio there. And then I know that this has to be the side opposite of B. So this is lowercase b. And then it doesn't matter whether I call this A or C or whatever, but I know that those are the two numbers. Oops, I missed something. Let me just write this a bit smaller. Okay, this is 44 squared plus 50 squared minus 2 times 44 times 50 cos b. Okay, so now what I can do is I can solve for that. Let's actually solve a few examples, shall we? Okay, so I have acute triangle DEF. Acute means that all three angles are acute. Okay, I know it looks a little bit too equilateral here. Maybe I'll make it look a little less equilateral. Okay. All right, so let's have a look at all these pieces of information. So lowercase d is 4.9 centimeters, lowercase f is 6.2 centimeters, angle E is 64 degrees, and I cannot use the sine law here because I do not have an angle side pair. So what I'm gonna do is I know that E is the angle that I know. Okay, it's the only angle in this triangle that I know, so I need to make sure that I use this version of the cosine law. All right, so now once I know this, I can fill in the information I know. So E squared equals 4.9 squared all right, and then we can just put that in our calculators. Okay, and then cos 64 is 0.4384. Okay, so let's combine all of this. Okay, and what we should pay attention to is that this number should always be positive. If it's not, you've made a mistake. It's positive because this is e squared, right? You can't have a negative number. So if you find yourself taking the square root of a negative number, you know you've done something wrong. So e is 5.98, okay, and that's gonna round to actually 6.0. So let's put that in our triangle. And now once I have this in my triangle, I can use the sine law. So now I can say like sine 64 degrees over 6.0. Like I don't need to use the cosine law over again. What I'm going to do here is I am going to solve for d. So I know that sine d equals 4.9 sine 64 degrees over 6.0. And that means that d equals sine inverse. Remember, d is an angle. 6.0. Okay, so what do we get there? All right, so I get that this is 47.2 degrees. Once I know d is 47.2 degrees, to find f, okay, all I have to do is take 180, subtract 64, subtract 47.2, and I get 68.8. All right, so that's the cosine law. Let's just do maybe a couple more examples here. And I did want to make you aware of a very common mistake, okay, just so you guys don't make it. Okay, so if I want you to calculate the angle C in this, I just want to show you the algebra, okay, because guys tend to make a mistake with this. So what I'm going to do is evaluate the powers of 2. So I get 5625 equals 8100 plus minus 2 times 90 times 100. Okay, now here is where the mistake happens. The mistake happens when guys take these three terms and they add them together. So the mistake would look like this. 5625 is 8100 plus 10,000 minus 18,000. So you're going to get 100 cos C. But that violates BEDMAS, right? Because there is multiplication happening. So this is a term all glued together. So you're not going to do this. I'm going to leave that up there just as a reminder. Okay, so we've got 5625, 8100 plus 10,000 minus 18,000 cos C. What we're going to do is bring the 8100 and 10,000 to the other side. And even though it looks weird, we've got 1800 cos C on this side. And then to get cos C by itself, what we're going to do is divide both sides by negative 1800, sorry. Okay, and then we're going to simplify. Okay, so these guys cancel out. So in the end, I'm going to get that cos C is 5625, subtract 8100, subtract 10,000, divided by negative 18,000. Sorry, 18,000. Okay, and I'm gonna get that cos C is 0.693055 repeating. Okay, so this makes sense because we always said that the cos of theta should always be less than 1. Okay, so this checks out. I'm going to say C equals cos inverse of this long decimal. Okay, so cos inverse, answer, C is 46.13 degrees. Okay, so please don't make that common mistake. So what I'm going to do now is I would like you guys to just look through these couple examples I'm going to do, and you can speed up the video and watch it and copy it into your notes. Then after this, I'm going to make a second video with lesson 6.7, which is just me solving a few problems. Okay, so feel free to speed through this part of the video and just copy the note down, okay?